Writing's not that easy, but Grammarly can help. This sentence is grammatically.
Let's say we're given the function f of x is equal to x squared plus 1. Mentioned in our analysis, our parabola gets way more interesting.
Okay. So last time we started in on functions. And one of the things that we said was that if we have a equation like this, 3x plus y equals 5, that we can identify this as a linear equation because the x and the y, both of our variables, have a power of 1. If it had anything other than a power of 1, then it would be some other kind of function. But we know that this is linear, and that it should fit the form y equals mx plus b. So when we're working with equations like this that are linear, we want to put them in the standard linear form, which for that would mean that we get y by itself. So we're going to take negative 3x from each side. And that gives us y equals negative 3x plus 5. Okay, now one more thing, to change this into an actual function, we need to give it a name. So I'll give it the name f of x equals negative 3x plus 5. F is the name, and x is what f is dependent upon. So what this means is as we change x, the value of f is going to change. Now, the other things that I said last time were that we have some important pieces and parts of this that we need to identify if we really want to understand our function. First, there's the slope. Slope. Okay, so the slope tells us how much the function is changing as we go from one point to the next. And so negative 3 is the slope in this case. And we usually want to write this as a fraction. The reason we want it as a fraction is because we can understand that the top part tells us how far to go up or down. The bottom part of that fraction tells us how far to go to the right. So first of all, the negative tells us that we're going to be going down. The 3 tells us that we're going to be going down 3 times. And then the 1 tells us that we're going to be going to the right once. That's to get from one point to the next. Again, this is how much change there is between one point and the next. The other part is the y-intercept. The y-intercept tells us basically how much this function has shifted from a normal. So you can imagine if we just had the function maybe g of x equals x. Well, then nothing has changed. Okay? So we start at 0, 0, then from one point to the next is up 1 over 1, up 1 over 1. The slope tells us that the rate of change between points is something that looks like this, and this y-intercept shifts the graph up or down. And really, this is all we need to know to get a graph of our function and to then see the overall behavior of our function. So let's go ahead and graph this. I'll just make a grid for us real quick. Okay. So once again, our slope is negative 3 over 1, and our y-intercept is 5. So the first point that I'm going to put on here is the one point that I know, and that is y equals 5. So 1, 2, 3, 4, 5 is right there. Again, this is the first point that we can put on because we know that the graph is going to cross through our y-axis. Oh man, YouTube compression really does not like this graph paper. Okay, so to get from this point to the next one, we use our slope, which tells us to go down 1, 2, 3 spaces, and then over to the right 1. Again, down 1, 2, 3 spaces over to the right 1, and we can make as many of those points as we want, but really we just need like 2 or 3. So now I can connect these dots. And I have a visual representation of our function. Like I said last time, a visual representation is a good thing to have because we are visual creatures. We understand this a lot better than we can just a big group of numbers. Any questions? All right. So again, this is a linear equation. Linear equations, first of all, the variables all have first power. Second, a linear equation, just like it says, makes a line, just a straight line. Okay. So what about other types of functions? Well, I've got one here that I pulled from Hawks. It gives me that a of x is equal to x minus 3 squared minus 1. Now again, a of x is just the name of the function. So again, a is dependent upon what x is. So as we change the values of x, a is also going to change. Now, as this looks right now, all of our variables are to the first power, right? But we can see here, we've got x minus 3 in parentheses squared, which by now we should all immediately be feeling, oh, actually this x is going to be squared, isn't it? So let's multiply this out and get a different version of this function. So if we multiply this out, this will be x minus 3 times x minus 3, and then minus 1. And so we multiply this, we get x squared minus 6x plus 9 minus 1. Simplify the 9 minus 1, and we get x squared minus 6x plus 8. So yeah, indeed, if we look at this, now we can see, hey, one of these things is not power 1 anymore, it's squared. So this is no longer linear. What kind of thing is this? Well, we've talked about it plenty by now. It's a quadratic function. And it operates much differently from a linear function. First of all, like we said, a linear function just gives us a straight line. A quadratic function is not going to give us a line, it's going to give us a single curve. So it'll look something like this. Okay? Now, if we want to graph this, if we want to understand the overall action and function of this function, then we're going to need to know a few points. So if we look at this curve here, it'd be nice to know this point right here, which is called the vertex. The vertex is where the curve turns around. It goes one direction and then turns around. The point where it starts turning around is the vertex. It's the absolute top or absolute bottom of a parabola. And if you didn't know, this curve is called a parabola. It would also be nice to know where it crosses the x-axis. Or the x-intercepts. And maybe we need more points than that, but let's see what we can get with this. Okay? So first of all, let's look at those x-intercepts, because this is actually something we already know how to do. If we think about these x-intercepts, it's where the graph crosses the x-axis. Now, anywhere along the x-axis, y is always going to be equal to 0. So if the graph crosses the x-axis, it's crossing where y is equal to 0. So all we need to do is we need to change a of x into 0, and then we can solve. Well, this better look pretty familiar. We've been doing this for the past few weeks. If we have a quadratic equal to 0, we can factor and then solve using our zero product principle. Okay, so let's figure it out. We've got an a of 1, which means we can use our shortcut, and a c of 8, giving us an ac of 8. Factors of 8 are 1 and 8, 2 and 4, And factors of 8 that add to get negative 6 would be negative 2 and negative 4. Now once again, like I said, our a, our leading coefficient is 1, positive 1. So we can go and use our shortcut and not have to go through the box method. So remember that says that we're going to have x as our variable, and then just add whatever number from this that we chose. So x minus 2, and then the other one would be x minus 4. And they're still equal to 0. All right, so now using our zero product principle, we can set each of these cases equal to 0. So x minus 2 could be equal to 0. X minus 4 could be equal to 0. Solve, and we get that x equals 2 and x equals 4. So what does this mean for us? It means that our graph crosses the x-axis at 2 places. It crosses at 2 and it crosses at 4, which makes sense because this is a curve. If it goes one direction and then back up, then of course it's going to cross twice. Okay, so we've got our x-intercepts. What about this bottom part, the vertex? Well, this is something we don't quite know how to do yet, but it's pretty simple. You just have one tool that's going to do this for you, and that is at the vertex, x equals negative b over 2a. Okay? So anytime that you're looking for the vertex, you know that the x portion of it is going to be equal to negative b over 2a. So all we need to do is we need to take our b and a from our quadratic and plug them in here. Now remember that our quadratic follows the form ax squared plus bx plus c. So in this case, our a is 1 and our b is negative 6. So I can plug those in. I now have x equals positive 6 because negative and negative is a positive, over 2 times 1, which is 2. And 6 divided by 2 is 3. So this gives us that the x portion of our vertex is at 3. But this isn't crossing an axis or anything. This is just a point. So before we can actually figure out where this point is, we've got to find not just the x part, but the y part as well. So what we'll do now is, since we know the x portion of it, we can take this, plug it back into our function for x, and it will give us out the y. So we have a of 3 is equal to 3 squared minus 6 times 3 plus 8. Okay? So let's simplify this and figure out what it is. 3 squared, of course, is 9. 6 times 3 is 18. Drop the plus 8 down. And so 9 minus 18, that's going to be negative 9. Negative 9 plus 8 is negative 1. So a of 3, or what we can call our y part, is equal to negative 1. Any questions? All right, let's graph this and see what we get. Like I said many times, x-intercepts in a vertex is all you need. That's 3 points, right? So let's see what it looks like. Okay, first, those x-intercepts. We said that we have a graph crossing the x-axis at 2 and at 4. So here's 2. I can put a point there. And here's 4. I can put a point there. Then my vertex was at 3, -1. So 1, 2, 3, -1 is right there. Well, I can see that it curves, yeah. But that ain't much of a graph, is it? So actually, we really do need one more point, and that is the y-intercept. Pretty easy to find. It's very much similar to the linear equation. We just plug in 0 for x, since anywhere along this y-axis, x is going to be 0. So plug in a 0 for x, 0 squared is 0, 6 times 0 is 0, 0 minus 0 is 0, 0 plus 8 is 8. So 1, 2, 3, 4, 5, 6, 7, 8 is right here. And so now I can fill in a little arm here. But you know, it'd be great to have points on the other side as well. We've got points on the left side, but how about the right side? Well, our vertex does something else for us. There is an imaginary vertical line that passes through the vertex. This imaginary vertical line is called the axis of symmetry. The axis of symmetry cuts the parabola into 2 even pieces. 2 pieces that are exactly the same, just mirrored. In other words, what you can do with this axis is any point that is on this side can be reflected over to this side. So like this point right here is 4 spaces away, or not 4, but 3 spaces away, 1, 2, 3. We can go another 1, 2, 3 from it, and we have another point. Not very good curve, but you get the picture. And so here's our problem. Now it doesn't stop there. It keeps on going past these points here, but this is really all we need to get a visual of what our function's like. Any questions? None? Okay. Let's try another one. Where is it? There it is. Okay. Let's check this one out. Here I've got h of x. So again, the function's name is h. It's dependent upon x. Is equal to 2x squared plus x plus 1. So again, things we would like to do, we would like to find the vertex, and we would like to find any kind of x-intercepts. Okay? So, let's find that vertex. This is pretty easy to do. Again, it's x equals negative b over 2a. So let's see. Our b is 1. So we've got x equals negative 1 over 2 times our a is 2, so that's 2 times 2. All right, so doing the math here, we get x equals negative 1/4. That's fine. Our coordinates do not have to be integers. They can be fractions. They can be all sorts of things. All right, but of course this is just the x part of our vertex. We also need to find the y part. So the way we do that is we take the x part, plug it into the original. So I've got now 2 times negative 1/4 squared plus negative 1/4 plus 1. Okay, let's see. Negative 1/4 squared is positive 1/16. And then positive 1/16 times 2 would be 1/8. Okay, so now we've got 1/8 plus negative 1/4 plus 1. Really, I want to get everything over the same denominator so I don't have to worry about that. So multiply this one by 8, this one by 2, and then this one's already fine. So now what we have is 1/8 minus 2 over 8 plus 8 over 8. All right, so 1/8 minus 2/8 is negative 1/8. And so what we get there is 7/8. So the x portion of our vertex is negative 1/4. The y portion is 7/8. Not the easiest thing to graph, but it's possible. All right, but how about those vertexes? I'm sorry, no, not vertexes, x-intercepts. Well, again, what we do to find the x-intercept is just make y equal to 0. So we get 0 equals 2x squared plus x plus 1. Okay, unfortunately, our a is not positive 1, so we're going to have to go through box method and all that. So let's see, a times c, that's 2 times 1 is 2. 2 has factors of 1 and 2. So how do we get positive 1 here out of these factors? Well, the answer is we can't. We could make one of these positive 1 negative, but that would make this a negative 2, and we want a positive 2. So again, the answer is we cannot factor this. Okay, well, not every quadratic is factorable. let's go through the quadratic formula. Again, that's x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we've seen this guy before. It's what we use when we can't factor something, when we can't factor a quadratic and we want to find x. Okay, so b is 1, so we've got negative 1 plus or minus the square root of 1 squared minus 4 times a, which is 2, times c, which is 1, all over 2 times a, which is 2. Okay, let's see what we get. Obviously, we got to simplify in here some. So 4 times 2 times 1 is 8. 1 squared is 1. So we've got negative 1 plus or minus the square root of 1 minus 8. That's negative 7 all over 4. Well, that means we have a bit of a problem, don't we? Because what's wrong with this square root? What is it about the square root that's going to give us something weird? The negative, yeah. We've got a negative underneath our square root, which means that we're going to have I somewhere in here. And what does that mean about our value for x? Well, it means that our value for x is non-real. Okay? In fact, let's have a computer graph this instead of us and see what it looks like. So, just enter this in real quick. There's 2x squared plus x plus 1. Whoops. Okay, so let's take a look at this. See what it says. Well, here's our graph. Where does it cross the x-axis? It doesn't. So that's what you can expect if you have a function that doesn't have x-intercepts. I mean, it does. It does have x-intercepts. It looks like this. So this part right here, the red, is our parabola. Okay? That's what we see on the paper in 2 dimensions. If we add another dimension at right angles to the x and the y, this one right here, this grid, this is our imaginary axis. And we can see here that, yeah, in 2 dimensions, it's just this flat curve right here. In 3 dimensions, it curves into the imaginary numbers. And here is what we just found. This is our real, or our non-real x-intercept. Again, for the purposes of what we're doing here, we're just going to focus on this. This means that we don't have x-intercepts. But in reality, what really is going on is we have x-intercepts, they're just in the imaginary plane. Does that make sense? Any questions?
There's no real, so I'm taking this on this, so when I put, x-intercept is there, but it's an imaginary number?
Mm-hmm. It's lifted out of the two-dimensional paper that we have. The paper is two dimensions. You can't have ink that's above the paper, right? But if we have a third dimension, which is that imaginary dimension, then we can lift that ink into the third dimension. Instead of having like a rectangle paper, we have a cube. Okay, so we're lifting that ink into the third dimension. That's where our x-intercepts are. Okay, so how do we graph this thing? Is it possible to graph it? Well, obviously it is. We can see the graph right here. But how did the computer do this? Well, what it did is first, it knows the vertex, which we also know. But also, we would have to use values that we calculate. We can calculate values at any point. Plug in any number for x and we get a value out for y. That's a point that we can plot on our graph. Once you plot that point, of course, you can use the axis of symmetry here to flip it to the other side as well. Okay? So if you don't have enough points to graph something, you can always just make them up. Just plug any number you want in for x, see what you get out for y, that's a point. Okay? Any questions? All right. Cool. Actually, wow, we got done early. So, one more time. Functions. So far we've seen two types. We've seen linear and we've seen quadratic. Linear functions follow y equals mx plus b. We talked all about that last time. However, quadratics, there's a few things that I want you to remember. First of all, vertex. This little formula right here is very important because it gives you your vertex and it gives it to you every single time. There actually is an equation for y equals instead of x equals, but it's huge and you don't need it. All you need is x equals negative b over 2a. Remember that once you get that, you get something like this, x equals something. Just plug that back in for x, and it'll give you your y. Once again, this is the vertex. If you want to know your x-intercepts, then you plug in a 0 for y, because anywhere that the graph crosses the x-axis, y will be 0. So again, we plug in a 0 for y to find the x-intercepts. And of course, solve. How do you find the y-intercept? Well, plug in 0 for x. It's the exact opposite. Anywhere that the graph crosses the y-axis, x will be 0. So plug in a 0 for x, see what you get. Typically, it's going to cancel everything except for that last number. So you could say that this is our intercept. And finally, sometimes you might be working on it, and you get to trying to find your x-intercepts. I'm sorry, your y-intercept. No, I'm sorry, your x-intercept. My goodness. Sometimes you might be working and trying to find your x-intercepts, and you get something like this, where you know that you're going to get a non-real number. What does that mean? Well, it means that the graph doesn't dip close enough towards the x-axis to actually cross it. So you won't have any x-intercepts, so move on. Find another thing. Find your y-intercept. Find other points around it you can flip through the axis of symmetry. Okay? So once more, any questions? None? All right. Well, good job today, guys. And I will see y'all on Friday when we'll be talking more about functions.
I will not be here Friday. We go to Austin play Concordia.
Man, everybody's not going to be here Friday. Maybe I shouldn't lecture on Friday. Maybe I should have a different. I'll think about it. Probably just plan for a lecture. If we do have a lecture, remember it's going to be on YouTube. Can you get to the YouTube channel?
Yes, sir.
Okay, good. So we probably will have a lecture. Just if you aren't here for that, get to the YouTube channel.
Okay.
Same for you. All right. So I'll see y'all on Friday, or not. I'm not going to see either of you on Friday.
Have a good weekend.
You too.